Okay, let's get started today's topic, BIM. As a case study, I'm going to introduce you a BIM-enabled design approach, okay? By using SketchUp, AutoCAD, 3D Max, Rhino, Maya, any type of geometric tools are available. And hopefully you are skillful at using SketchUp, AutoCAD, of course, including 3D Max, okay? But what's the difference in real-world project? Let me introduce an actual BIM-based remodeling, building remodel project that is currently working in my lab, okay, with my students. Let me introduce you one actual project. Okay, there is an 40-year-old apartment in Yeongwol City, Korea, okay? There are only blueprints. Take a look. Hand drawing blueprints, okay? Very old-fashioned but conventional architectural standard drawings. How to make design and reconstruction. AutoCAD plan drawing, SketchUp modeling, 3D Max modeling. What is your option? Many options, of course, but we used Revit. This is the Revit interface, okay? Building information modeling tool interface. Representatively, we used the most popular one, Revit, okay? And this is the Revit, exactly what you need to do today's lab exercise. So from blueprints to this 3D model, this is existing building. So what if you want to use SketchUp just for visualization, okay? What if you use AutoCAD? It's very nice to represent 2D plans, but we already have a blueprint, hand drawing. Why we need to draw exactly same to this blueprint, okay? All those are taken by my iPhone, okay? I took this picture at Yeongwol City. This is government building for housing welfare. Korea government's new direction of new housing welfare model. So this building supposed to be occupied by some elderly people or someone who's disabled or someone who need to be taken care of, okay? Anyway, this is existing building modeled by Revit. What if you model this one into SketchUp? How long it takes? Several hours. AutoCAD, 3D Max, of course, many hours you need. But we convert this blueprint into Revit model in couple of hours in Revit, okay? And you're gonna find out why it's very convenient and fast, relatively, compared to geometric tools. Because we're gonna have lab exercise today, Revit, okay, modeling this floor. Okay, this is remodel project. This is existing, current building. Take a look, very roughly modeled, roughly designed geometry. We don't need to put details because this one going to be reconstructed, redesigned. So how about the scenario? A is existing building. How about B, extension? This is horizontal expansion. First scenario. How about vertical expansion? That's second scenario. Third scenario is here, annex building, okay? New constructed building connected with this building or connected through exterior walkway or bridge, whatever, okay? Many possible scenarios. So we are designing this scenario, not this existing building, okay? That's why we use the BIM for convenient and easiest model. So let's take a look. Another reason is here. By using this model, we need to analyze its structure and some design quality and sometimes building code, fire code, and we need to apply lots of design alternatives. That's why we need this kind of flexible and powerful integrated model. So actually, this is the final model. I'm going to show you the example. Take a look. these are the floor plans, module plans, and designs for various people, okay? Elderly, disabled, someone who need to be taken care of, and so on. So those components should be loaded into this building. But building design, there are many alternatives, okay? So we have many scenarios. But this is a remodel. We don't have long time. So we have to finish design as soon as possible for rest of the actual project. Actually, this building is now under the construction, okay? So let me show you what are the scenario. First scenario is building mass, okay? This is original building, but this is vertical expansion and new construction and its connection, okay? And also different type of new construction. Anyway, this is architecture remodel. But actually the most important thing is interior module. Take a look. This module for one, okay? One elderly, one disabled person, or anyone who live alone. Another module for two. The area and the components are all the output result of the research, okay? For future, the minimum requirement for, in terms of the housing welfare direction, Korea government. Anyway, this unit for two. Another module shows you the three separate bedroom, okay? Three separate rooms, but they share this kitchen and living room area, which means a module for three. So 1 to 3 persons can be occupied by this one single module. Technically, we have three alternatives, okay? Three alternatives and three different modules. So we can make this kind of 3 by 3, 9 alternative technically, right? So all those representations created by BIM tool, Revit, okay? Not 3D Max, SketchUp, AutoCAD. So design alternative number 1 shows you the various design modules, housing units, and its shape. Alternative 2, 3, 4, 5, 6, okay? 7, 8, 9. All they are different spatial allocation, different building mass shape, but originally, here is the original building unit currently existing, okay? So this diagram shows you the time frame. 2015, we supported design as an assistive tool for building remodel. At the beginning of the project, this is existing building, but alternative designs, and this is the final design, okay? Now this one is under the construction. And actually this is Yeongwol city, but there is another city, Hamyang city. Korea government also in charge of making this housing welfare model, so we supported this one. So take a look, this one single point. This one single point means hundreds of pages manual to support their design and construction planning and the rest of the project process. Not only for visualization, amount of additional data we have. What kind of things? Solar study, energy analysis, special program review, circulation analysis, including 3D visualizations. So here are some examples, okay? This is the precise location of that existing building at Yeongwol City, Korea. So we have address, longitude, altitude, which means we can use weather data. We know the solar path, okay? We can take a look, solar study, how surrounding building has the affected shade or something to this building or from this building. Take a look. In this location, this building has always this sun path band. Okay, what is this? winter, okay? Winter period, sun pass, and this is summer. So anytime in 365 day in year, sun will be located anywhere, somewhere in this band, okay? That's the simplified solar study example visualization. This application knows where is the living room and where is private room, okay? So this kind of simplified color scheme, very useful for architect designers, okay? Shared space, private space, building common space, okay? And also it can export through this kind of Excel file. Very easy to calculate its area. Revit knows this dining room has 7 square meter, okay? This living room has 22 square meter, precisely measured by Revit, okay? It's not measurement by human in manual, it's automated calculation. And also energy analysis. I told you this is government building. So energy bill, the cost, maintenance cost can be paid by government, Yangwon City, okay? So they are very interested in the maintenance fee for their budget or something. They want to reduce the cost. So we can provide the energy analysis result even in early phase of design, thanks to this BIM tool, okay? Revit has this energy simulation tool. So this diagram, it's too small font, but actually this one displays how much money you need to pay for these buildings, heating and cooling annually, okay? How much kilowatt this building requires. All day going to be analyzed, even in design phase, okay? How? Revit knows the location of this building, which means it has weather data. And Revit knows the envelope, building envelope, windows, where is window, where is opaque concrete. And thereon, Revit knows general thickness of the external wall has how much U value or R value. U value, R value means some heat transfer related equation, specific data, okay, we need for calculating cooling demand and heating demand and so on. We don't need to know that one right now, but anyway, my point is, what if you used SketchUp? Can you do that? It's not possible, okay? 3D Max, AutoCAD, they are just the geometry. Very good for visualization, but this kind of additional tasks cannot be done, okay? So this is the final design. Let me quickly show you this example, okay? Actually, this is one of our reports. We submitted this one more than 10 times. We made this 100-page slide in a couple of hours, thanks to BIM and Revit, okay? So this is typical submission from our side to Korea government, okay, one of the report. So my students are working for something like this one, but this is one of the funded research projects. Very small project, actually, this one was. Okay, table of contents. The first thing is visualization. Even if this one has very rich information about this building, anyway, people very interested in visualization things. So take a look. Site plan, okay? Site plan. This is existing building. This is satellite picture. And this is our new building shape, okay? In this final design. So take a look. Floor plan, but this is not AutoCAD plan. This is Revit auto-generated floor plan. That is why this one has color. Blue color shows you private space. Gray color, shared space. Green color, building common, okay? Corridors, stairwell, and so on. So 3D representation and 3D representation in this way. And this is Revit interface in 3D view. You're going to be asked to model something like this. in today's lab exercise, okay, for this building. Series of visualization examples. Site plan with shade. So is this shade just visualization purpose? No, this is precisely measured real shadow, because Revit knows the compass, okay, where is north direction, and Revit knows where is the sun, if this one assigned the time, okay? So something like this. Overview and just simple 3D representations. And even this kind of building representation can be export this kind of very easily and simply made walkthrough animation. This animation, how to make it in 3D Max, last time in the lab exercise, you have learned how to make this kind of visualization. Placing your camera and move the camera, okay? But in Revit, just simply draw your working path. And then Revit going to export movie format following your working moving path, okay? Very easy to create this kind of working movie, okay? This is level 3 walkthrough movie. You can take a look, roof garden and the third floor, second, and the piloty area on the first level, and so on, something like this, okay? So this is very easy to make video-based representation exported by Revit. Let's take a look some interior features. This is floor plan in Revit, and the number here means the location of camera, okay? What you need to do is placing the camera, and then you can get this kind of visualization. I know this is not photorealistic render. This is just architectural, conceptual visualization. But you don't need to render. You can just simply save the view in JPG format or screen capture. Okay, number 1 camera, number 2 camera shows you this is shared space, okay? Shared space for some people, elderly people, okay? It's a sort of living room here and dining area, kitchen area. One of the bedroom unit for one person, okay? Another example. And some more camera views are here. All day generated, easily extracted from 3D BIM model. So how about this one? This is not SketchUp warehouse model or geometric model. All they are component library. So we can download this chair object, door object, this refrigerator object, or this even TV object. And you can place TV and the TV table, your bed or lighting object inside of your building model, okay, BIM model, Revit model. This is the example of Revit-based easy and quick representation. Of course, this is not aesthetically beautiful or unique, simply because this is for elderly or someone who needs to be taken care of by government. Okay, this is housing welfare building, not a commercial building, retail interior design for public or someone who pay for lots of money. Okay, this is kind of minimal requirement for new type of housing welfare model currently developing by Korea government. Some more visualization from the existing building. This is existing building and its floor plan view. Swipe out everything and alternative planning, alternative modeling by using given CAD file and mass study and slab object interior fill. But this one doesn't have interior fill, okay? Because this is building mass study. interior modules can be loaded by given module design file, okay, separately. Anyway, at the end, this one can be modeled something like this. One of the design alternatives, okay, and some more detailed design, and the color scheme for the spatial planning, allocation, spatial analysis, space review for this design alternative, and so on. This is the final, okay? So what we can do using this BIM model. First, solar study, okay? Based upon the time and the date, winter, summer, we can visualize the effect of the solar and sunshade. This is precise data, exactly same to real-world simulation. So this is Revit interface. You can turn on and off the sun's location for this building. So this shadow, even interior shadow, is exactly same to your real building later, if that one is realized, okay? Even in design phase. Preliminary energy analysis, take a look. And cooling demand, heating demand. In summer, we need to use electricity for cooling. Winter, we need natural gas for heating, okay? Or oils. This is windrows. Yonghwa City has some type of southern or western bound wind direction. It has strong, relatively to east wind, okay? Thanks to this weather data, this is provided by another Korea government agency who's in charge of managing weather data of Korea. So we can use them for energy simulation and windrows analysis or energy bill estimation and so on. Area calculation. Let's take a look at this one. This one shows you how many housing types supposed to be placed inside of this building. So for 8 persons, for 1 person or 2 persons, how many households, how many modules, and how many people can be occupied by this housing welfare building. Total 88 persons, okay? And this one shows you which module can be loaded to which household and which type. So in terms of the household and personal area occupation, we can visualize the analysis report, something like this. Thanks to given numbers, all they are extracted from BIM model. What if you used AutoCAD 3D Max? This is not possible, okay? You have to measure one by one. If you draw the floor lines for this room, and then you can measure the area, even in AutoCAD or SketchUp. But it's not easy to extract entire room's area in a couple of seconds, okay? Only by using BIM, something like this application, Revit or ArchiCAD, you can make it, okay? How about circulation analysis? Different space types displayed here, and thanks to BIM, we can figure out total number of space, total number of windows, even total space height and area, okay? Take a look. The graph is here, okay, circulation analysis graph. Computer can display you which unit is the closest unit from the exit. Which unit is the most far from this exit? What does that mean? Okay, disabled person, someone who need to be riding wheelchair, okay? They supposed to be living close to exit, okay, for their convenient access. If their units going to be modeled very far from the exit, we need to provide them some elevators or ramp structure or some additional things. It's not cost effective, okay? So we need to measure at least measure this kind of working distance based upon this BIM model. Very precisely modeled working distance and so on, okay? So you can find out the circulation graph to represent this kind of representations, okay? So here are my simple preview of how this kind of BIM-based design and its application analysis can be done by thanks to BIM rich information we have, okay? So next thing we need to do is we need to take a look at solid modeling features in Revit. As I introduced you lots of times before, we are still dealing with surface-based 3D model, but solid model, parametric model, even building information model, they are the topic next semester, but this is the preview for next semester. So we need to differentiate the difference between surface-based 3D, conventional 3D, and the new way of 3D, building information modeling, okay? That's my topic. As I introduced you before, surface 3D, solid 3D, it's not easy to figure out in this example, but how about this one? Hollow inside, that's surface 3D. Solid inside, solid model. So what you have walked through, SketchUp, 3D Max, AutoCAD, Rhino, Maya, Blender, or almost every single game has this surface-based 3D model. But Revit, ArchiCAD, CATIA, Digital Project, Getty Technologies parametric design tool for freeform is Digital Project based upon CATIA. CATIA in charge of designing mechanical equipments or automobiles or some very mechanical and some different type of industry objects, not for the building. Anyway, some of the BIM tools, most of BIM tools are totally based upon solid model, okay? That's the difference. In solid model, we have Boolean operation, constructive solid geometry, union, intersection, plus minus operation. So this is Revit interface. Revit has extrusion. Do you remember how to create 3D model? Same, okay? Extrusion. Another extrusion, revolving, okay? Sweeping, section profile, and pass. This one going to make this 3D. How about this one? Pass, section profile. But this one automatically turns and gonna create realistic object like this. Another one, Boolean operation. Single cube minus this cube, and then final product. That is Boolean operation. All they are Boolean operation, okay? Intersection, union, plus minus operation in its geometric equation. All they are solid model. So there is no editable poly, okay? This kind of operation going to create model. Take a look, one example. Section profile and its path. And then you can get this kind of Windows panel, curtain system panel, okay? How to make whole panel? Define your object and parametrically define the cylinder and A minus B. So you can get this final product. What if you change your L value, the R value from 700 to 500. The hole size is going to be shrinking, okay? Smaller holes, simply because the R definition here is the parameter, okay? You can control. Next thing we are going to take a look at is parametric modeling features in Revit. What is parametric modeling? Actually, next semester we're going to deal with some details with Grasshopper and Dynamo, but in this class, let me briefly introduce you. There is another term, feature-based modeling. Take a look, this sweeping, section profile, and the path. We can get this geometry. If you control this shape, this feature, you can control the total shape of this geometry, this object. Similarly, we can say that this is a part and this is assembly, okay? So your part can be one of your assembly part. So at the end, you can get this final product. Take a look. If this is geometry model, what if you want to make this one for 2 or 3? In 3D Max or in SketchUp, what you can do? If you rescale this one, the couch is going to be looking like this, okay? Thicker or oval shaped leg and this arm also going to be changed, okay? But if you have width value and it's controllable, editable, take a look. Couch for 1, couch for 2, for 3. So same thickness for the arm and the same thickness for this frame, legs, okay? Do you see the difference? This is the parametric model we have, okay? So this is parametric design, parametric model approach. Simply, I can tell you without any experience. Let's take a look at this design. Very non-uniform organic shape design. What if you design this one using 3D Max? Designing by 3D Max means designing by mouse clicks, okay? So design and visualization in this computer file, that's okay. But how to realize in real world? So manufacturer, they need to know the width and height thickness and the height of this stand, okay? But in SketchUp model, in Rhino 3D Max model, we have to measure one by one. Because this one designed by mouse click, okay? You cannot mimic this one again, okay? This is final geometry. This one doesn't have logic. So designing by parameters, constraints, equations, in other words, design by logic, which means editable, okay? Editable by designers. And then we can realize this design in real world. That's the point of the parametric modeling. Nowadays, we are living in sort of non-uniform design features, building exterior, building facade, and building interior features. You know where is this place? This is interior of DDP, okay? DDP has very organic formed building facade, okay? Non-uniform, so-called free-form design. Because of that building facade and mass structure, even interior finish also has non-uniform, organic shape, an angled column, and something different looking stairwell, and the structure, ceiling structure, and so on. Nothing is unique except this floor. Floor is supposed to be flat anyway. And this kind of geometry, in last time, we have learned how to make this kind of geometry simply by using 3D Max. But for the real world project, we need to prepare, how to manufacture, how to install, how to construct, okay? That is so-called considering constructability or manufacturability, okay? If your goal of your design is visualization, that's okay using 3D Max, SketchUp, AutoCAD, Rhino. But if your goal is realization of your design, we need to take care of manufacturability, constructability, okay? That is why we need to use this kind of BIM. In other words, design and construction, in a certain standpoint, they are integrated, okay? So parametric design using Revit, let me show you a quick example. This is one of the lab exercise in next semester. Next semester, we're going to deal with Revit and 3D Max, advanced 3D Max based visualizations. This semester, we are dealing with 3D theory and some lab exercises in fundamental 3D Max. But next time, we are going to deal with 3D Max animation making, video presentation, and very advanced visualizations in mental array, as well as BIM using Revit. Anyway, let's take a look. You need a part. This part is going to be loaded into your assembly, your project, okay? And then you can get this kind of thing. What if you want to change thickness, depth? Simply change the parameter, H parameter and W parameter, and then your final design going to be updated automatically. What if you change your design surface? This one can be interior wall, even roofing structure and building facade, anything else. Auto update, okay? Building facade, you can design in this way, and this one can be loaded exactly same to this one. What if you change your part definition in triangular shape? All day going to be updated like this. Okay, you define this one, those two parameters, okay? And you defined your project. This one can be your ceiling structure, roofing structure, or even building surface, whatever. And load that into this surface. And then you can make this kind of real product. Revit knows how many panels, parts this one has, okay? You don't need to count one by one. What you need to do is U and V number of parts you want to assign to this surface. That's it. Zoom in, you can still select this part and you can take a look. This object is here, okay? Related properties. So this is the way of making thing by using Revit. But in real world, I told you, we are in digital design and visualization class. Still designers need 3D visualization. So that's why I show you this one before. Revit-based design visualization, including today's architectural visualization, not this kind of photorealistic. I show you lots of Young apartment remodel visualization example today, but this is photorealistic render. Take a look. Take a look, this one. This is not a picture. This is Revit model and Revit's mental array-based visualization. I told you, Revit knows sun's height and the location, simply because this building has address. The meaning this one has address is simply this one has precise location in altitude, longitude on this planet. That is, we can precisely calculate sunshade, okay, daytime. And all these components are Revit part, Revit component, Revit family. What you need to do is load them and try to render. This table originally has its color and surface characteristics in terms of its visualization. That is why this one has reflection, okay? simply because it has its material. So this kind of architectural visualization, you can find out lots of reference websites in Google. And I show you last time this example. Architecture model in Revit and mental ray photorealistic render visualization in 3D Max. So in daytime render, no artificial lights. You can get this one in 3D Max. If you change your time to night and placing some artificial lights, especially on this lighting structure, and you can render this one in mental ray. Okay, so using 3D Max and Revit is much better than 3D Max and SketchUp or any other tools, AutoCAD or something. Okay, this is the reason, another reason, exactly same to the course topic this semester, digital design and visualization. So next week, based upon the model you're gonna make today, this building level 5 in Revit, next week we will be asked to create something like this visualization in mental ray 3D Max. Okay, but today we're gonna build BIM model for this floor, this building. Okay.